Good morning, everyone. Math 151, we're doing related rates. Essentially what we have here is a formula. This is the area of a circle. And the radius variable and the area variable, these are changing through time. And we normally are going to be asked to find things like dA by dt. And in this particular question, question 1, we're being asked, let's see. I'm just writing down all the information we need. There we go. So you have the area of the circle, pi r squared, and question A asks us to find this guy, and it says to find it in terms of the r by dt, right? So the formula for getting dA by dt is you differentiate A with respect to r, and then you multiply by the derivative of r with respect to t. And when you differentiate this one with respect to r, you get 2 pi r. And right now in question A, we leave that guy the way it is. So that's what they mean in question A when they ask you to find the derivative dA by dt with respect to that. Now, all they do in question B is they ask you to find out what number it is when r is this guy and dr by dt is this. So you just go 2 pi 33 times 2. Got my calculator handy. And 2 times 33 times 2 more is 132 pi. We're good. That's it. If possible, give the answer as an exact value. If they say in the question to 2 decimal places, then, you know, multiply those two together and round off to 2 decimal places. The next story is each side of a square is increasing at the rate of 6 centimeters a second. Now, if you imagine a square, and we'll call the x's x, then the area of this square is x squared. And you have told me that it's increasing at the rate of 6 centimeters per second. And we are being asked to find the rate at which the area is increasing. So find the rate at which area is increasing is that. When the area is 81 square centimeters. Right. dA by dt is the derivative of the area with respect to x times dx by dt. The area of this guy is 2x, and dx by dt is 6. And now all we need to do is figure out who x is. In an easy question, wouldn't we just say x was 9 or 7 or 22? In this case, we're being asked to find out what this is equal to, right? And that means we need to find x, but they gave us this guy. But since the area is x squared, isn't that just a disguised way of telling you x is 9? And so 2 times 9 times 6, which I believe is 108. And the units here are square centimeters per second. If you hear some barking, that is my dogs decided that a leaf fell on the yard or something, and now they have to make sure that it's frightened away. God, she has a weird sound. Can you hear their barking? Is it just me? Because my earphones. Yeah. She sounds so brave, but she's only a puppy. She's frightened to everything. Question 3 is just, we done one yesterday. Question 4 about the volume, we did one similar to that. So I'll move on to a different kind of situation. This is like question 5. And now we have 4x squared plus 9y squared equals 100. And you're told that x and y, as you'd expect, are functions of t. You're given 2 questions. I'll do the first one. If the value of dy by dt is 1/3, find the value for dx by dt when x is equal to 4 and y is equal to 2. So the guy we're looking for eventually is going to be that one. So this is not a equals or v equals. This is 4x squared plus 9y squared equals, but we're still going to essentially do it the same way. I am going to differentiate everything with respect to t. And the way that's going to work is 4x squared gets you 8x times dx by dt. And 9y squared is going to get you 18y times dy by dt. And if you differentiate a number with respect to t, you get 0. Are you comfortable with the derivative with respect to t of this guy is with respect to x, ax, then you finish with dx by dt, and the same with that. Isn't this very similar to chain rule or implicit differentiation for that matter? Right. Someone was going to say something, but I kind of cut them off. What was it? Are we good? Okay, now all I'm going to do now is plug in all the numbers that they gave me. Well, x is 4, so 8 times 4 dx by dt, plus y is 2, so 18 times 2 times dy by dt, which is 1/3. And now I have that. And that's going to become 32 dx by dt plus 12 equals 0. Right, remember the goal here is to find the number for dx by dt. What do you think we should do now? This is what we're looking at. But eventually I want to know what dx by dt is equal to.
You'd start by subtracting 12 from both sides.
That's what I would do. And to finish, what would you do next?
Divide by 32.
And if you can, make it nice. Are we good on that, guy? Any problems? Whoops. By the way, it's negative. We cool with that?
This is the rate of increase. Is that what they're looking for?
Well, they're finding what is the rate at which x is changing, right? So if you drew that, it would actually be an ellipse. And as time goes on, this ellipse is changing. And what might be happening is that both are getting bigger, in which case this would be positive. But couldn't one of them get wider and the other one come down? So when you see a negative number for dx by dt, doesn't that mean that the x value is actually decreasing at this point?
Right.
Right. Now, if it was positive, it would be getting bigger, right? It would be increasing. I could imagine that. Can you imagine that the y's got longer, right? Went bigger that way, but the x's got smaller, right?
And we're just finding it for in the sense of the x value.
At one particular point, so at the x comma y value, because it's both together. So we're finding out, I guess, what's happening at this point here, right? And at this point here, the x value is reducing at that particular instant in time.
Okay. I wonder, would it help us if to visualize it if we put it into maybe like a graphing type of situation? And
in these questions, it probably wouldn't help. And the reason for that is that the information that are giving here is saying, look, if the Y values are increasing by a third, what does the X value have to do? Well, in this case, it has to decrease by, we found out the number is -3x. And I guess the reason for that is this, that if this guy squared plus that guy squared always equals 100, if you make this guy bigger, won't that one have to get smaller so that the total stays as 100?
okay,
Now, you could have told me that that was -2, which means if this guy gets smaller, wouldn't that one end up be bigger? And so this would have been a positive number when we finished.
And so is the 0 for them to be balanced?
Yes.
Okay.
Are we good with that one? Now we got 6 is a spherical ball. I'm not thinking this question is quite fair, so I'm going to make it easier for you. The radius of a spherical ball is increasing at the rate of 2 centimeters per second. So you have just told me that the rate at which the radius is increasing is 2. Don't worry about the units. And then the question says, is the surface area of the ball increasing or decreasing, and eventually what number, when the radius is equal to 7? Okay. What's unfair about this is that not everybody has memorized all the formulas to do with spheres and cones and so on. Does anybody know the formula for the surface area of a sphere?
I think it's like 4/3, radius cubed.
Well, what you gave is the correct answer for the volume of a sphere. But you were close. The surface area is 4 pi r squared. That's the kind of thing you might have to go looking up, right? If you can't remember the formula for the surface area or the volume of something, you would look it up. This is the guy, right? Now, we are going to find out what is happening at this point, given that that's true. So I'm going to find the rate at which the surface area is increasing, which is what they're asking us to do. And it's going to be the derivative of this with respect to r times dr by dt. And this becomes 8 pi r times, I guess, dr by dt. And we know that the radius is 7. So it's 8 pi 7 times 2. And I get 16 and 7 16s are on 12 pi. Would you agree then that the rate at which the surface area is changing is a positive number? So that means it's increasing, isn't it? And it's increasing by that amount. That one's a much more standard one once you know that formula. So if you come across a guy and you say, I don't know the volume of a cone, or I don't know the volume of a cylinder, you can look it up and you should be good to go. Now, this guy is a version of question 5 that we did a few minutes ago. It's x squared plus y squared plus z squared, and it's going to equal 9. No, sorry, misread it. It's going to equal 6. We're also told that the rate of change of the y value with time is 7, and that the rate of change of the x value with time is 6. And we're being asked to find the rate at which the Z value is going to change. And we're being told that X, Y, and Z is the 0.221. So that's basically all the information that we've been given. So we know that X is going to be 2, Y is going to be 2, Z is going to be 1. We know this derivative is 7. We know that derivative is 6. And we're going to find this one. So I'm going to tackle it the same way we did question 5. If you differentiate each of these with respect to X, or with respect to T, the X squared gets you 2X times dx by dt. The Y squared gets you 2Y times dy by dt. And the Z squared gets you 2Z dz by dt. And the derivative of a number is always 0. So that keeps it all balanced. And now I'm going to plug X as 1. So 2 times, sorry, X is 2, times dx by dt, which is 6, plus 2 times Y times dy by dt, which is 7, plus 2 times Z times the unknown value dz by dt. Would you agree that looks very similar to the one we did with the ellipse? It's just got more bits to it, just. So what I'm going to do now is multiply them. And we're really just solving for an unknown. The guy I'm covering up with my finger, couldn't I call him A, B, or anything else? Aren't we basically just trying to find the number underneath my finger, right? We're trying to find dz by dt. Okay. Take me down the pathway to finally getting dz by dt. What should we do first?
If you add 24 and 28.
I have to put little strokes through my Z's because they look like 2's. So that's a 2 and that's a Z. Okay, that's a good start. What do you do next?
Back to 52.
Great. And to finish?
Divide by 2.
Yeah. And hey, it's another negative number. Does that make sense that if the X's and Y's get bigger, don't the Z's have to get smaller so the thing still adds up to 6? Are we good with that? Any questions? Well, you should have a question there. That's 26. Now it's fixed. Hey, I caught that one on my own.
So if it wanted you to find like the coordinates for those, like I had 2, 2, 1, would you like find the rates and then multiply the rates by the number, the original one? Like if it did ask you to ever find the coordinates for that.
The only way they could ask you that would be fair for the coordinates, wouldn't they have to tell you at least 2 of the 3 and then you could figure out the last one? I mean, if I told you X was 1 and Y was 1, for example, then 1 squared plus 1 squared plus this guy would be 6. That means Z squared would be 4, so Z would probably be 2. But no, I think the questions I've seen, you're either given this guy, right, just told right off the bat that's who he is, or if it's one of the earlier questions, they'll tell you the area is 81, but you can figure out, what the radius is, from that, because if I know the area, I can figure out the radius. So that would be the other situation. I can't think of a situation where you would be told maybe all of this, including that one, and somehow be asked to find out the X, Y, Z. I'm not even sure that's quite possible. Okay, question 8 is a story. That means things are going to get much more complicated. There's the ground. In question 8, a plane is flying horizontally at an altitude of 2 miles. Here's my little plane. And it's flying at an altitude of 2 miles. And it's flying at a speed. So I'm going to imagine it's traveling in this direction, right? And I'm going to call that distance x. And it's traveling at a speed. So dx by dt is 540 miles. And at this point here, there's a radar station. Looks like that, a radar station. And we're being asked to find the rate at which the distance from the plane to the station is increasing when it has a total distance 4 miles away from the station. So we're being asked to find this guy here. That's the distance from the radar station. And I'm going to call that, I'll call that y. And we're being asked to find the rate. So we're being asked to find dy by dt. When you ever see rate, you stick it under t. And we've to do it when that distance, or is it this distance? When the total distance is when it's total distance of 4 miles away from the station. Oh, so we're being told when that distance there is 4. Wow. So I've got a picture. My plane goes from here to here. I got a radar station. That distance there is going to be 4 miles. This distance I'm calling it x, but I know it's speed. And we're being asked to find dy by dt. And it might look superficially like we're missing some information. For instance, I don't know what x is. Any suggestions how I could find out what number x is? Right, that distance from here to here.
Pythagorean theorem.
Right, and if you do 16 take away 4, and I'm doing that in my head, so that's always fun. 16 take away 4. Are we happy about where I got the distance of square root of 12 from? Right, that's fixed. That's for Pythagoras, right angle triangle, right? So far, so good. Now, the next bit is the killer. If that wasn't bad enough, we need to create an equation or a formula, if you prefer, that contains x and y. So forget about the numbers, right? Forget about that guy, forget about that guy. This guy is going to be x, this guy is going to be y, and this guy is going to be 2. We need to create an equation using nothing but x's and y's. The reason that 2's there is because that's definitely 2 all the time. Can you imagine this changes depending on how long you wait before you measure things? Any suggestions about how we could get these together as an equation? Is there any relationship between these 3 sides that we could use?
Are we talking about a conversion factor?
I'm not sure what that means, but I suspect not.
We're talking about Pythagoras? Or
We
using
are.
like a sign?
We're talking about Pythagoras. So according to Pythagoras, isn't the big one those 2 guys? Agreed? So I'm hoping to create an equation that has these 3 guys in it. That's always going to be the hardest part of these questions. Pythagoras says the hypotenuse squared is the other 2 squared. C squared equals A squared plus B squared, might be the way you'd remember it. Now I'm just going to rearrange it a tiny bit, and it's going to look like that. Now, once you've got that guy set up, we can now start doing the derivatives of everything with respect to t. So y squared becomes 2y dy by dt. Take away 2x dx by dt, and the derivative of 2 gets you 0. So if I have this equation, I can now differentiate it with respect to time. So y squared is 2y dy by dt. This fella is negative 2x dx by dt, and the derivative of the number 2 to keep it balanced is 0. Now, 2 times 4 times dy by dt, which we don't know yet. Take away 2 times x times dx by dt, which is 540, equals 0. Do you see that we've now got everybody except one thing as a known value? We know that y is 4, came from here. We know x is root 12, came from here. We know dx by dt is 540. Now, that becomes 8y dy by dt. Take away, I'm going to have to bite the bullet sometime, so why don't I do it now and just turn that into a decimal? Because they want the answer to the nearest whole number anyway. So 2 times the square root of 12 times 540. It's about 3741 to nearest whole number. Yes.
How come 2 squared went to 2?
This 2 squared here went to 2? Or this 2? Which 2 are we talking? Is it here to here?
Like, yeah, like the first, sorry, my computer isn't keeping up with where your fingers are. The 2 squared on the first line. You rearranged
this 2 squared?
Yeah, so you have y squared equals x squared plus 2 squared. So
Uh-huh.
you rearrange it, and then that goes to y squared minus x squared equals 2. Is
4.
why is that a 2?
It's not, it's a 4.
Oh, okay. Sorry,
The good news is that it still turns into 0, so that's good because I don't worry about it now.
Okay, thank you.
So, you're welcome. If you add 3741 to both sides, and then you divide everybody by 8 to the nearest whole number, 3741 divided by 8, it's about 400. What do they say? They say it's 468. Yeah, 468 looks good. And if you want to know the units, it's miles per hour. So what made this question so tricky? This was created by just reading the information. They told me the speed of the aircraft was 540. I put in a vertical or horizontal distance representing the distance that the aircraft traveled, and I'm calling that X. It's 2 miles off the surface, that's fixed. And that distance is how far away from the radar station the aircraft is. They told us to find this fella. And they also told us that the distance from here to here, the guy I'm calling Y, is equal to 4. Once I knew that was 4, Pythagoras allowed me to get this number. Then I went back to that picture and just used the plane X and Y so I could generate an equation using Pythagoras. Rearranged it so that all the variables were equal to a number. Then from this point onwards, it's a little bit more standard. If you differentiate that with respect to t, if you differentiate this piece with respect to t, and differentiate 4 with respect to t, you get 0. You can then plug in 2, the y, the unknown guy, take away 2, the x value, and dx by dt, which eventually became this number, which added to both sides, then divided, and we got our answer. A lot of things that you had to create on your own wasn't handed to us on a plate. The later questions are typically going to involve us doing things like that. And I'm scanning through every single one of the ones that is left is pretty much going to be its own unique puzzle where there's things that are missing. So question 9 then, here's the story. The length of a rectangle is increasing at the rate of 5 centimeters per second. Okay, you've told me it's a rectangle, so I'm drawing it. Would you agree a rectangle has a length and a width? I like X and Y, so I'm calling one of them X and one of them Y. Now, the rate at which its length is increasing is 5 centimeters per second. So you've just told me that the rate at which the length is increasing is 5. I'm not going to bother with the units, you know, they sort themselves out at the end. And its width is increasing, they tell me. So its width is this guy, and it's increasing at the rate of 7. So if you imagine this rectangle is growing in size with time, with t, right? And it's growing like 7 going this way and 5 going that way. So it's growing asymmetrically. And they asked us to find the rate at which the area is increasing when the length, which is X, is equal to 13 centimeters, and the width, which is Y, is at 4 centimeters. I got all of that out of one sentence. I just kind of read each piece and created it. I've got a rectangle that's getting bigger. The length is getting bigger at 5 centimeters a second. The width is getting bigger at 7 centimeters per second. We want to find the rate at which the area is increasing, and it's going to be at this snapshot of time. I need a formula. In this case, it's the area. And isn't the area X times Y? Agreed? Now, this is the first time we've ever needed to do a related rate where the two variables are multiplied. They've always been X squared plus Y squared, right? They've always been separated with an add or maybe a subtract. Now, that is going to add a lot of problems because this is the first time that we've had to deal with this. What method do you think I'm going to use to find the derivative of X times Y?
Product rule.
Product rule.
Exactly. And aren't we going to have to be careful about how we use the product rule? Because this isn't just a normal everyday product rule, like X times sine X kind of product rule, right? It's a bit trickier than that. So it's F dash J plus F of G dash. So far, so good. When you differentiate something with respect to T, you have to be a little bit more careful about it. If you differentiate an X with respect to T, you get 1 times dx by dt. And then you leave the second guy alone. You leave the first guy alone. Now, if you differentiate y with respect to t, don't you get 1 dy by dt? Isn't it a bit like the chain rule come implicit? It's a little bit of one and a little bit of the other, right? It's kind of a merging of those two things. Are you happy about where the 1 dx by dt is coming from and the 1 times dy by dt is coming from? Because this isn't just a normal derivative. Now, in a funny kind of way, it would be easier if this was x squared y squared, because wouldn't you do 2x times this guy and 2y times that guy, and it might be a little bit more obvious what's happening. So I now have this fella. He is y times dx by dt plus x times dy by dt. And I think we should be able to plug in numbers now. We know that y is 4 and dx by dt is 5. And we know x is 13 and we know dy by dt is 7. So 20 plus 91. I make it 111. And if you're interested in the units, because it's an area and everything with centimeters, it's 111 centimeters per second. In WebAssign, they tell you the units, so you only need to remember the number. What that is allowing us to do here is to look at dynamic situations. That just means situations, something that changes with time, right? Areas of things changing with time, volumes of things changing with time. So we now know that this rectangle is increasing at that rate at this particular snapshot, right? So if you stopped it when the length was 13 and the width was 4, what's going to happen in the next second is it's going to grow by an extra 111 square centimeters. So that's a pretty big increase in area, isn't it? It's got massive, quite large. Of course, if that number was negative, wouldn't the rectangle be shrinking in some way? That would be a smaller answer. Now, if you looked at this guy and you looked at that guy, would you agree there's not an awful lot in common with them, right? Because they're kind of unique. Okay, we got one last one for today. And this is a version of question 10. And it's another unique question. So I'm just reading out the information. A street lighting pole at the top, a street light is at the top of a 15-foot pole. So here's the ground. Here's the street light right at the top of a lamppost. I would call it a lamppost. And this is 15 feet, which means this distance is fixed, right? Lampposts don't change height, right? Whatever they are now, they're going to be the same height in 10 seconds from now. A man is 6 foot tall, is walking away from the pole. So I'm going to do my little guy, and he's here. And this guy is also a fixed height. Would you agree he is 6 foot? And he's going to be 6 foot in 10 seconds from now. Now, this guy is walking, so this fella is walking away from the pole at the speed of 5 feet per second. So I'm going to put a dot here, and I'm going to do this guy, and I'm going to call that X. And you have told me that he is walking away at that speed. So you've basically told me what this fella here is, right? Now, they then talk about his shadow, or the tip of his shadow, which is here. And they said that's the tip of his shadow. That's where it ends up. And they say, how fast is the tip of his shadow moving when he is 45 feet from the pole? So a lot of stuff happening here. They want us to find that guy. So I'm going to call that distance the tip of the shadow. Why? And we're trying to find that guy. So we're trying to find the rate at which the tip is moving, dy by dt, when he is 45 feet away from the pole. And that is, now, did they mean 45? Oh. If you're telling me he's 45, aren't they telling me, since it's he they mentioned, that that's 45? So that's a bit weird, if it wasn't already weird enough. So I'm going to draw a simpler version with only the things I want right now. This is fixed. This is 15. This guy here is 6. I'm going to call this distance here X. I'm going to call this distance here Y. And none of the numbers about, all this stuff, I'm not going to worry about them right now, because I am going to try and figure out a formula that connects X's and Y's, right? Just like we had to make one over here. This time it's not going to be Pythagoras. Hopefully some of you have met what are called similar triangles. And similar triangles are two triangles which have essentially the same shape, but are different sizes. And the big triangle is 15 and y, and the little baby triangle is 6 and x. So far, so good? Now, in similar triangles, corresponding sides are in equal ratio. What that means is that the 15 on this one, if you divide it by the 6 on that one, it's the same number as this guy divided by x. So similar triangle says corresponding sides are in equal ratio. So if you divide corresponding sides, you always get the same number. If I cross multiply this, you get 16y equals 15x. If you then divide both sides by 6 and you divide by 3, there is the equation connecting x and y. Are you happy about the equation and how I got it from the similar triangles situation? And then something amazing is going to happen. You are going to think this is going to get really ugly because I have to figure out what this is going to be and what this is going, how we're going to factor it in. Well, let's show you why it's surprisingly simple. Differentiate everybody with respect to t. This guy gets you 1 dx by dt, and this guy gets you 5 halves times dx by dt, which means that dy by dt is simply just 5 halves dx by dt. And I know what dx by dt is. They told me. They told me it was 5. So the answer that we're looking for is actually that number there. And it's feet per second. Now you might say, well, what about the 45 feet, and what about the distance here and all these other things? I never needed to use them. And do you know what that tells me? Isn't this a fixed number? In other words, doesn't your shadow go at 12.5 feet per second when you're walking at 5 feet per second? No matter where in the journey, right? What would that be the equivalent of? Doesn't your shadow get longer the further away from the pole you get? So I guess that's what that's reflecting. And I know it's a long, well, for me, it's a great long time. Did you ever try and catch your shadow? Didn't it always run away from you? And isn't the reason it's going to run away from you, isn't it always going to be faster than you? Right? So if you speed up, doesn't your shadow just speed up as well? If you were doing it with a lamppost. And this is a good point for us to finish. So I will hang about for any questions, if there is, or if there are any. Last name and bye-bye.